Okay, hypothesis testing. This is the chapter, and this is our first section from this chapter, basics of hypothesis testing. So, this is one of the most important chapter, I would say, and particularly in this section, we're going to introduce what are the things we're supposed to do in this hypothesis testing. Okay. Um, so whenever we try to apply the hypothesis testing, we use either proportion, means, or standard deviation. In this course, we are going to particularly use proportion and means. Okay, so what is hypothesis? In statistics, a hypothesis is a claim or a statement about a property of a population. So whenever we try to make some kind of claim in real life, that is called hypothesis in statistics. And hypothesis test is a procedure for testing a claim about the property of a population. So there are two different type of hypothesis we use here. Null hypothesis, which is denoted by H0, like you can see here, that's the null hypothesis. That's the statement that the value of the population parameter, such as sometime proportion, sometime mean, sometime standard deviation, you're going to see proportion and mean in this course. And null hypothesis means those parameter equal to some claimed value. For example, let's say proportion of some sample is equal to some number, like let's say 0.5, then that's the null hypothesis. What is alternative hypothesis? Alternative hypothesis is alternate of that null. Okay, so we denote, we might use H1 or HA or HA. I'm going to use this H1 notation for the alternative hypothesis. It's the alternate to the null hypothesis we make. Okay, so for the alternate hypothesis, because the null hypothesis means it's equal value, alternate means either it would be less than that value or greater than that value or not equal. So there are three different possibilities for alternate hypothesis. So these are the steps we need to follow while doing this hypothesis test. There are 8 steps, as you can see. First of all, we have to make a claim. We need to give symbol, and then based on that symbolic form, we're going to create our null hypothesis and alternative hypothesis. And then we are going to select a significance level. Normal, very common significance level are 5% or 1%, like 0.05 and 0.01. And then after that, we need to identify the test, what kind of test we're going to use. There are especially 2 different type of test method we're going to use. That's called p-value method or critical value method. And then after finding the p-value or critical value, we compare those value with the significance level alpha, and then we make our decision. And finally, we try to go back to the problem and then make our conclusion or finding in generic non-technical terms. So these are the steps okay, so let's look at these steps for hypothesis testing. Step 1, we need to use symbols to identify the claims and its alternate, step 1 and step 2. And by using those symbols, we create null hypothesis, which is H of 0, as you can see here, and then its alternating hypothesis, which is H1. So after that, we try to use significance level, which we denote by alpha. This is actually probability of rejecting null hypothesis when null hypothesis itself is true. So for example, let's say alpha is 0.01. So what is the probability of rejecting null hypothesis while it's being true is 1%. So if you want to make less small mistake, then this alpha value should be small. So the significance level alpha for a hypothesis test is the probability value used as the cutoff for determining when the sample evidence constitute significance evidence against the null hypothesis. So yeah, we need to normally we use a significance level as a 5% or 1% or 10%, but most common use significant level is 5%. And now based on the test we have given, based on the problem we have given, uh, we do have to find test statistics like a g-score or t-score or chi-score. It depends on what type of problems we have given. Some of the examples are, let's say if you have given proportion, then we find we use the normal sampling distribution and we find the z value. This is our test statistics. That's the formula we're going to use. If we're using mean, then we use the t sampling distribution and we find the t value by using this formula. So in this course we are going to use only proportion or mean. Sometimes mean can also be used for normal distribution. In that case, this is the formula we are going to use. The fourth one, standard deviation or variance, it's just given here. We're not going to use it, but that's also can be used. Another step is after finding the test statistics, now we need to find out the p-value or critical value. There are two methods we are using, either p-value method or critical value method. Okay, so find the test statistics. That means either g-score, t-score, in our case in this course, or sometime chi-square test as well, chi-square test, which we are not going to cover here. So find the test statistics, and after that we can use either p-value or critical value. So if you go back here, either we can use the p-value method or critical value method. So for the p-value method, we need to find out the p-value, and for the critical region, we need to find out the critical value. So for the critical region, if it's a two-tailed test, then we are going to use the area. As you can see here, the critical region is in the two extreme region under the curve. If it's a left tail test, then critical region is the left side, and if it's a right tail test, then the critical region is the extreme right side. And these are the symbol we use for the alternating test. S1 is not equal to some value, meaning it's a two-tail test. S1 is less than, that's a left tail test. S1 is greater than, that is the right tail test. Depending on what test we are using, we find the critical value. Okay, so for the p-value method, first of all, find the p-value based on the problem or the test statistics you have given, and then you start the problem, and depending on what tail you are using, if it's a left tail, we can find the p-value, which is area to the left of the test statistics. So we can find the p-value using the method we discussed in previous chapters. Like, how do you find the p-value? We can use a TI-83 calculator or TI-83-84 calculator or StatCrunch. So those are the technology we can use for finding the p-value. And based on the situation, if it's right tail test, then we're trying to find out the p-value for the area to the right of the statistics here, test statistics here. So we would like to find out the p-value, area to the right of the test statistics. So what test statistics you are using? Maybe it's a g-score or maybe the t-score. So based on the g-score or t-score test, we try to find out the p-value. And then if it's a two-tail test, then again there are two different ways. If it's the test statistics is to the right or left of the center, to the right or left of the center. If it's left, then we use this area. The p-value is twice the area under the curve. If it's right, then it's a twice the area under the right side of the curve. So do not be confused about the p-value and then these symbols. This p means it's a population proportion. This p hat is a sample proportion. This p-value is the probability of a test statistics, at least as extreme as the one found from the sample data. We're going to see a couple of examples, and then you'll be able to see this notation one more time. Critical value, like this is also we already covered in previous chapter how to find the critical value. In hypothesis test, the critical value separates the critical region where reject the null hypothesis from the value of the test statistics that do not lead to the rejection of the null hypothesis. So now after finding the p-value and critical value, this is what we do. We compare the p-value with the significance level alpha. If p-value is less or equal alpha, then we reject the null hypothesis. If p-value is greater than alpha, then we fail to reject. Okay, so there are only two scenarios. Either we reject the null hypothesis or we fail to reject the null hypothesis. Same goes to critical value. If the statistics is in the critical region, then we reject the null hypothesis. If the test statistics is not in the critical region, then we fail to reject the null hypothesis. So that's how we reject the null hypothesis or fail to reject the null hypothesis. So finally, after that, we always have to make our conclusion in non-technical terms, okay, which can be understood by anyone, okay, without knowledge of statistics process. So this is the final wording, conclusion wording, we can write in this way. So start your problem. And now there are two different directions. Does the original claim contain the condition or equality? So if contains condition or equality, if it's yes, then do you reject the null hypothesis? If your answer is yes, this is your conclusion. If your answer is no, this is your conclusion. Does the original claim contain the condition or equality? No, then there are two options and you go like that. So I'm going to use this picture one more time when doing a problem or two. So just keep in mind, that's how we can conclude. Finally, confidence interval for hypothesis test. A confidence interval estimate of a population parameter contains the likely value of the parameter. So here is the one thing we have to do. We should reject a claim that the population parameter has a value that is not included in the confidence interval. So after finding the confidence interval, we should reject a claim that the population parameter has a value that is not included in confidence interval. So where we use confidence interval, which parameter gives you a more accurate result with the confidence interval? Proportion, no. Mean and standard deviation, yes. While doing this type of hypothesis testing, there might be two different type of error can occur. Type 1 error. So whenever we do the mistake of rejecting the null hypothesis when it is actually true. Null hypothesis is true, but because of some reason we reject it. If we do that, then error happens. That type of error is called type 1 error. So we use alpha notation for the type 1 error, which is actually the probability of happening the type 1 error. Probability of rejecting the null hypothesis when null hypothesis itself is true. Type 2 error is probability of happening type 2 error, which is beta, is actually failing to reject the null hypothesis. We're supposed to fail the null hypothesis, but we don't do that. Even null hypothesis is false. That's where the error happens, and that's called type 2 error. We're going to do some problems from your homework here. So let's start with the number 1. As you can see here, the answer is already given, so I will quickly go over this. A formal hypothesis test is to be conducted to test the claim that the wait time at the Space Mountain ride in Walt Disney World have a mean equal to 34 minutes. So the null hypothesis means always this mean equal 34, so always equal sign. Alternate means the alternating of this claim, it's supposed to be equal, so that means not equal is its alternate. There are two possible outcomes we have. One is reject the null hypothesis, or maybe fail to reject the null hypothesis. These are the only two things we can conclude. So we always, after doing this hypothesis test, there will be only two possibility, two answer. Either fail to reject the null hypothesis or reject the null hypothesis. Okay, so last question is it possible to conclude that there is sufficient evidence to support the claim that the mean wait time is equal to 34 minutes? No, the answer is no, because hypothesis test can only find sufficient evidence to support a claim when the claim does not contain equality. If it's equal, then no matter how many hypothesis tests you do, you cannot create the sufficient claim which support the claim that the mean equal to the value you have given. That's number one. Let's go to the next problem. As you can see here, claim is fewer than 91% of adults have a cell phone. In a reputable poll of 1042 adults, 81% said that they have a cell phone. Find the value of statistics. So as you can see, particular problem, as you can see here, you're talking about the proportion because it's a percentage. So we are going to use the first formula for finding the test statistics. Okay, in this case, as you can see here, this is the formula we are using. So the formula is, the test statistics is p cap minus p over square root of pq over n. I guess that's the right formula I'm using. Let's go here, p cap minus p over square root of pq over n. So this is the test statistics. So we're going to use this formula for finding this value. I'm going to use calculator here. Okay, so as you can see, what is that here? Fewer than 91% of adults have a cell phone. So that's the claim, 91%. So here 91% is the population proportion, so 0.91. So p is 0.91. q is complement of p, which is 1 minus 0.91, so it's a 0.09. It's a 0.91. That's a q. N equal, it's a total number is 1042. P hat, it's 81%, I guess. 81%, yes, it's 81%. So it's a 0.81. So we are going to use this value for finding this z value. So as you can see here, p cap is 0.81. 0.81 minus q is p is 0.91, parenthesis close, divide square root, and then p is 0.91 times q is 0.09, divide by 1042, parenthesis close, and then hit enter. That gives us negative 11.28. So it's a negative 11.28. That's how you find the test statistics. So let's look at this problem. The test statistics of g-score 2.3 is obtained when the testing the claim that p is greater than 0.7. Identify the hypothesis test as being two-tailed. If the proportion is greater, the hypothesis test is right-tailed test. And the second is find the p-value. P-value means area under the curve to the right of this g-score, because this is the right-tailed test. So we need to find out what is the area under the curve. We can do that by using this normal CDF function. We would like to find out the area under the curve from the g-score 2.3. That's the lower g value, and the upper g value is, let's say it's a million. So we would like to find out the area under the curve to the right of this g-score. So this is what we are planning to do. So you have, this is the right-tailed test, and there is a g-score 2.3. We want to find out the p-value is area under this curve, and for that we can use this normal cumulative distribution function here, and that by taking this command, it takes the lower z value, and then upper z value is, it's a 10. I'm taking some, let's say 1 million, which is very huge number. Eventually it will give you all the area between these two g-score, so which is, in this case, it's a 0.0107. If you want to round it to the, let's say 3 decimal place, it would be 0.011, right? 0.011. That's a 3 decimal place. Okay, so now, because let's go to the part C. Using a significance level alpha is 0.05, should we reject if p-value is less than alpha? But here you can see, yes, p-value is less than alpha, then we should reject the null hypothesis. That is our conclusion from the p-value test. If you go back here and find out the p-value test, where is that? Okay, this one. If p-value is less or equal to alpha, reject the null hypothesis. So in this problem we found the p-value 0.01, and if the p-value is less than alpha, then reject the null hypothesis. So we are rejecting the null hypothesis. In this case, the null hypothesis is proportion should be equal to 0.7, but we are rejecting that null hypothesis, so proportion should be greater than, which is the alternating hypothesis, should be greater than 0.7. So this is our answer. Okay, so this is a next problem. This is a next problem here. Test statistics of z-score negative 1.16 is obtained when testing the claim that proportion is not equal to 0.588. This is a two-tailed test. We know that the significance level is 10%, complete part A and B. If the significant level is 0.10, that means because it's a two-tailed test, we have to find out the area under the curve such that the value of the area, the significance level is 0.05. So we can do that. So this is what we're doing here. Look at here. So because it's two-tailed test, we would like to find out the z-score. That is the z-score. Okay, because it's a two-tailed test here, such that you see here the area under the curve two side is 10%, because that's 0.10 means it's a 10%. So area on the left side should be 0.005, area on the right side should be 0.005. So we would like to find out the critical values. Critical values means it's a g-score. This g-score, they are called critical value. So so this is minus. This is minus because it's on the left side of the value here, and this is the plus. So how do you find this z-score? That's a critical value. So we can use a calculator. We can go to the second variance, and then we can use inv-nerve that takes the area, which is area under the curve is 0.05, and gives the g-score such that to the left of that g-score the area is 0.05, and in this case it's a negative 0.64 if you want to round it to the 2 decimal place. You can get the same g-score but the positive g-score for this one. So the answer for this one is negative 1.64 and positive 1.64. These are the two critical values. Critical value means g-score. Okay, so this third part, since this test statistics, which is negative 1.16, is not inside the critical region, so we should not reject the null hypothesis should not reject it. As you can see here in this picture, our critical values are negative 1.64 and positive 1.64. Anything to the right and to the left is called critical region, but our test statistics, which is negative 1.16, it's inside here, which is not part of the critical region. So we should not, as a null hypothesis should not be rejected. Okay, so identify the type 1 error and type 2 error. The proportion of the people who write with their left hand is equal to 0.29. So type 1 error is the mistake of rejecting the null hypothesis when it is actually true. So which one of this is type 1 error? Rejecting the claim that the proportion of the people who write with their left hand is 0.29 when the proportion is actually 0.29. That's a type 1 error. Type 2 is fail to rejecting the null hypothesis actually when it is false. So fail to reject the claim that the proportion of the people who write with their left hand is 0.29 when the proportion is actually different from 29. That's type 2 error.